This is 3-3, proving lines parallel. The 3 warm-up problems you've not seen before, so I'm going to reveal the answers for you. It says to state the converse of each statement. The converse is when you switch around an if-then statement. So instead of saying if A equals B, then A plus C equals B plus C, we would say if A plus C equals B plus C, then A equals B. Okay, so let's switch this if-then statement here, meaning that we're going to switch around these two pieces. So if angle A and angle B are complementary, then the measure of angle A and the measure of angle B equals 90 degrees. And in number 3, if A, B, and C are collinear, then AB plus BC equals AC. So the converse of a theorem is when you switch around the if and then. That will help us with our new converse theorems that we're going to be learning, converse postulates as well, that we'll be learning in this section. So our first converse postulate is what we used to have before. I'll write out for you. If parallel lines are cut by a transversal, then corresponding angles are congruent. Well, the converse of that, remember we're going to switch our if and then. The wording's off just a little bit on this one, but if corresponding angles are congruent, then the 2 lines are parallel. So if you look in this image right here, we have 2 congruent angles. Angle 1 is congruent to angle 2. Since those are sitting in the corresponding spots, we can now say that the corresponding angles are congruent. Therefore, M is parallel to N. So notice how we write that. Line M is parallel to line N. Okay, use the converse of the corresponding angles postulate and the given information to show that L is parallel to M. So it says angle 4 is congruent to angle 8. Well, I'm looking at my image and I'm marking that up. Those are corresponding angles. So since the corresponding angles are congruent, then line L is parallel to M by the converse of the corresponding angles postulate. Now let's look at measure of angle 3. Measure of angle 3 is 4x minus 80 degrees. The measure of angle 7 is 3x minus 50 degrees. Notice those are corresponding angles, and they're telling us that x is 30. Well, if I replace these x's with 30, let's see what happens. We end up getting 4 times 30, which is 120, minus 80 is 40 degrees. So the measure of angle 3 is 40 degrees. Then we do the same thing here. 3 times 30 is 90, minus 50 is 40 degrees. So the measure of angle 7 is also 40 degrees. So since these corresponding angles are congruent, we now know that L is parallel to M by the converse of the corresponding angle postulate. So these converse theorems, or postulate in this case, are used to prove that lines are parallel. Here's one that you can try if you want to pause the video. Try it on your own and hit play when you're ready. Okay, so measure of angle 1 is equal to measure of angle 3. Measure of angle 1 is equal to measure of angle 3. Well, since they are equal, they have the same measure. Measure of angle 1 is congruent to measure of angle 3. And so therefore, line L is parallel to line M by the converse of the corresponding angle postulate. Okay, next one, measure of angle 7 equals 4x plus 25. The measure of angle 5 equals 5x plus 12. Those are corresponding angles, and it's saying that x is 13, so let's plug 13 into both of these x spots. We'll see measure of angle 7 is equal to 4 times 13, which is 40 and 12, 52 plus 25 is 77 degrees. And the measure of angle 5 is equal to 5 times 13, 65, plus 12, 77 degrees. So since they're both equal to 77 degrees, then line L is parallel to line M by the converse of the corresponding angle postulate. Now this is the same idea, but these are all theorems, and we have converse of the alternate interior angles theorem, converse of the alternate exterior angles theorem, converse of the same side interior angles theorem. Using the given information in the theorems, you have learned to show that R is parallel to S. Well, it says angle 4 is congruent to angle 8. Angle 4 and angle 8. Those are supposed to be alternate exterior angles. Since those alternate exterior angles are congruent, we now can say that line R is parallel to S by the converse, it's really important, of the exterior angle theorem. Okay, measure of angle 2 and measure of angle 3. We're given that measure of angle 2 is 10x plus 8, and measure of angle 3 is 25x minus 3. Notice, I better get rid of these congruent symbols because these are actually not congruent. Let me remark this. Measure of angle 2 and the measure of angle 3. Notice those are same side interior angles. Well, same side interior angles are supposed to add up to 180 degrees. So if I plug in this 5 into both spots, we get 50 plus 8, which is 58 degrees. So the measure of angle 2 is 58 degrees. And the measure of angle 3 is equal to 25 times 5, which is 125, minus 3 is 122. And if we add these up, 122 and 58, you'll see that we get 180. And 180 degrees is what we wanted for same side interior. So these are supplementary. And so, therefore, line R is parallel to line S by the converse of the same side interior angle theorem. Here's a couple more for you to try. If you want to pause the video, try it, and then hit play when you're ready to see me do out the work. Okay, measure of angle 4 equals the measure of angle 8. Measure of angle 4 is equal to measure of angle 8. So measure of angle 4 is congruent to the measure of angle 8. Since they're congruent and they're alternate exterior, these lines are parallel. Line R is parallel to line S by the converse of the alternate exterior angle theorem. Okay, measure of angle 3 and the measure of angle 7. Those are supposed to be alternate interior angles. So they should be congruent if these lines are parallel. So let's see, we have x is 50. So I'm plugging 50 into both of these x spots. Well, 2 times 50 is 100, so the measure of angle 3 is 100 degrees. And the measure of angle 7, that's 50 plus 50, which is 100 degrees. So therefore these angles are congruent. R is parallel to S by the converse, because that's how we prove things are parallel, the converse of alternate interior angle theorem. You won't be expected to fill out this proof, but I'm going to provide you the answer anyway, just so you can take a look at what's happening here. So we're given that P is parallel to R. We're also given that angle 1 is congruent to angle 3, so I filled that in next. I know because of the parallel lines that angle 3 and angle 2 are congruent because they're alternate exterior angles. And now the transitive property states that if angle 1 is congruent to angle 3 and angle 3 is congruent to angle 2, then angle 1 is congruent to angle 2. It's basically kind of just eliminating that middleman, the angle 3 there. So angle 1 is congruent to angle 2 by the transitive property of congruence. And now we can prove that L is parallel to M. Remember, we use converse theorems to prove that. So L is parallel to M by the converse of looking back at angle 1 and angle 2, they're corresponding angles. And so it's converse of the corresponding angles postulate. We've talked about this earlier on in the year, but another thing you need to know is that vertical angles are congruent. So for instance, angle 2 and angle 3, those are congruent angles. Use the diagram and the given information for the proof. So given that angle 1 is congruent to angle 4, since we know angle 1 is congruent to angle 4, we also know that angle 1 equals angle 4 because of the definition of congruence. I'm going to put the m in front of that. The measure of angle 1 is equal to the measure of angle 4. This next part should say angle 3 and angle 4 are supplementary. So let's look at that. Angle 3 and angle 4 are supplementary. That was given. So then what do we know about angle 3 and angle 4? Well, the measure of angle 3 plus the measure of angle 4 is equal to 180 degrees. That's the definition of supplementary angles that's given to us there. And so now I have, this went from measure of angle 3 plus the measure of angle 4 equals 180 to the measure of angle 3 plus the measure of angle 1 equals 180. So measure of angle 4 became measure of angle 1. Well, that's substitution when we change something out. We substituted in that value. Okay, and then like I highlighted before, for the vertical angles theorem, that was that the measure of angle 2 is equal to the measure of angle 3. Now we're saying the measure of angle 2 plus the measure of angle 1 is 180. Well, since the measure of angle 2 is equal to the measure of angle 3, we just replace the measure of angle 3 with the measure of angle 2 from this step. So that's substitution as well. And now we can prove L is parallel to M, of course, with a converse theorem. That's how we prove lines parallel, with a converse theorem. So converse of the same side, interior angles theorem.